In this Maths Olympiad preparation video, we're going to look at how to solve 2 to the power of x plus 4 to the power of x plus 8 to the power of x is equal to 155. So here's our equation. We're looking for x's that are real numbers. The first thing to notice with this is that we've got 2, 4 and 8 here. These are all powers of 2. So if we swap these for their power form, we end up with 2 to the power of x plus 2 squared to the power of x plus 2 cubed to the power of x equals 155. Now, by our laws of indices, if we have a power of a power, we can switch them around. So, for example, 2 to the power of 2 all to the power of x is the same as 2 to the power of x all to the power of 2. They're exactly the same thing. So if we do that, we now end up with 2 to the power of x equals 2 to the x squared plus 2 to the x cubed equals 155. We've got a cubic. To make this a bit easier to solve, we're just going to let y equal 2 to the power of x. So we end up with y plus y squared plus y cubed equals 155. If we just rearrange this to get everything on the same side, we end up with y cubed plus y squared plus y minus 155 equals 0. So we now need to solve this cubic equation. Now, cubics can be very difficult to solve, but one thing that can make it easier is if we can find one solution, we can then reduce this down to a quadratic, which is a lot easier to solve. So we need to find a value of y that will fit into this equation. One thing to notice is that our cube and our square and the y itself are all positive. So this tells us that we're not going to be looking for a negative y, because a negative y here would create a very negative y cubed, which then isn't going to be balanced out by everything else. We need that y cubed plus y squared plus y to be positive. As we're looking at 155, a very sensible first guess would be 5. So let's let y equal 5. We would then get 5 cubed plus 5 squared plus 5 minus 155, which simplifies to make 0. So y equals 5 is our solution. If this didn't work, it would be worth trying a few others just to see if we can find it to then simplify. So as y equals 5 as a solution, we know that we can rewrite our cubic as y minus 5 times by a quadratic of the form y squared plus ay plus b. We know it's just going to be y squared and no coefficient there because we've only got y cubed at the beginning. Now it's up to you how you solve this. We could do some long division. What I'm going to do though is I'm just going to expand that right hand side and solve the simultaneous equations. So if I were to expand that right hand side, we could see that we'd get just y times y squared. That's the only thing that would give us y cubed. To get y squared, we've got our minus 5 times y squared, and we've got the ay times y. So we'd end up with a minus 5 times y squared. To find the y, we would get the minus 5 times the ay and our b times y. So we get b minus 5a times y. And then on the end, we'd have minus 5b. And just checking, if you think of each of those brackets as 2 separate terms, we've got 6 terms there, which has come from a 2-term bracket times by a 3-term bracket. So we've got everything we need. We can now compare this to our left-hand side. So looking at the y squareds, we've got a minus 5 on the right. That must be equal to the 1 on the left, which means that a is equal to 6. The next easiest one to look at is the last term. So minus 5b is equal to minus 155. So we get that b is equal to 31. And if we just put them into our coefficient of y, we'd end up with 31 minus 5 times 6, which is the 1, which we've got on the left as well. So now we know that our cubic can be rewritten as y minus 5 times y squared plus 6y plus 31 equals 0. So now we've reduced our equation down to the multiple of a linear expression and a quadratic expression, we can solve it. We've got 2 brackets multiplying together to make 0, so our solutions must be when y minus 5 is equal to 0 and when y squared plus 6y plus 31 equals 0. So the y minus 5 is nice and easy. Y equals 5, there's one of our solutions. For the second bracket, I'm going to solve the quadratic. Again, there are multiple ways to do this. I'm going to complete the square. So we've got 6y there. So if we halve that, we'll end up with y plus 3 all squared. I then subtract the 3 squared, the 9, just to cancel it out again. And I've still got plus 31 equals 0 on the end. Adding the 9, subtracting the 31, we get that y plus 3 all squared equals minus 22. So y plus 3 is equal to the square root of minus 22. If we're square rooting a negative, we're going to have an imaginary number here. So y is equal to minus 3 plus or minus I root 22. Now, as this is a complex number and we're just looking for solutions in the real numbers, we can ignore this one. We're just going to look at our y equals 5. Now, remember from before, we said that y is equal to 2 to the power of x. That's how we defined y. So 2 to the power of x must equal 5. By our definitions of logarithms, that means x must be equal to log base 2, 5. Let's change this into normal log form now. So if log base 2, 5, again by our laws of logarithms, this is going to be equal to log 5 over log 2, which is approximately equal to 2.322 if you're looking for it in number form. If you've enjoyed this video, don't forget to subscribe to the Doing Maths channel or check out some more of my videos by clicking on the links here.